Yes, please.
Thank you for this very interesting series, which it turns out is relevant even in our virology space. For instance, ivermectin is extremely potent against yellow fever based on cell culture testing. And we've been having an active discussion with Médecins Sans Frontières about the implications of that. I wonder whether you're being have you had an opportunity to ask the questions regarding reproductive toxicology? And there was reference in the last lovely modeling presentation to the impact on other mosquito species. It's unfortunate that Aedes, as I understand it, is less responsive to ivermectin. Can you comment? And have you had any opportunity empirically to look at other species? So reprotox, other mosquito species.
Reprotox? Okay, I'll take reprotox. During licensure, it was shown that ivermectin can be teratogenic, but it was shown in doses that were toxic to the mother. So this was shown in monkeys and rats, and for mice, it's much more sensible. But monkeys and rats, it showed it could be teratogenic, but the doses that was needed to achieve that effect were already toxic to the mother.
So forgive me for drilling a little deeper into that. Although safety in pregnancy is important, also potential impact on the male. And this has been done with other antihelminthics, mostly in the veterinary market, as well as for ivermectin. Has any work been done in terms of distribution into male fluids? And of course, the agency here in the States will want to know the answer for the combined administration of DHA piperaquine plus ivermectin.
Okay. About male fluids,
yes.
I'm not aware, but there is a systematic review ongoing about safety of ivermectin in pregnancy. And
okay.
I guess that assesses both partners.
And then can anyone comment on the other species, particularly Aedes? I know the literature suggests reduced viability in egg laying. Can you say anything more than that from the empiric human studies?
We'll have Brian take that.
The Aedes species, the LC50 is, oh man, I'm forgetting. 60 to 600, yeah. We've published some papers on that. It's can be very high to the point where you probably can't get those levels unless you go to some of these very high doses.
So 600 nanomolar, is that what?
Nanograms per milliliter.
Okay.
In blood. But things like Culex mosquitoes are also, or at least Culex pipiens and Quick fasciatus tend to be pretty resistant as well, like Aedes aegypti, but then Culex tarsalis, our main West Nile vector in the Great Plains in California, is quite susceptible. So I think some of the species are all over the map in their tolerability to ivermectin. Now, things about, if you talk about floral honor and stuff, I think that's still being reviewed.
Thank you.
I would like to point out that every Anopheles species tested to date is susceptible to ivermectin at either human or animal relevant concentrations, depending on the system that was used. Anopheles diarrhea is probably the most tolerant, so we're reaching the maximum of diarrhea.
Thank you.
Hi. I mean, really beautiful data. I'd like to, I guess, ask a question about cost. So 600 micrograms of ivermectin, that's about 9 tablets for an average person for 3 days in a row. So that's 27 tablets every month for 3 to 6 months. So that's maybe 70 or 100 tablets. I mean, at the current price that you can get that from Merck, that's a very expensive intervention. Do you have any progress on a generic pre-qualified ivermectin? I mean, I have a slight biased interest because I'm using it for scabies as well. So,
all right. So during the meeting we had in Geneva, one of the discussions was that it would be good to have some healthy competition, and clearly having this pre-qualified, I think, would be an attractive option for many generic producers if there is somehow a recommendation to use in certain settings, because for you as a producer, it would mean you have some access to new markets that could be covered if pre-qualified by money from, for example, the Global Fund. And the number of tablets, I'm glad you asked. There's some work being on that, and I won't go into detail, but there's tests going on single tablets with higher doses.
Hi, Kimberly Blade from CDC. I apologize, I missed the first couple of presentations, but any thoughts on selection pressure and what impact that might have long term, especially for host preference, since mosquitoes do not need human blood to survive? So maybe this is a question for Hannah in terms of the modeling. You only looked at a couple of years, so maybe those effects don't kick in quite so fast, but any thoughts about including them in models going forward, that there may be a shift in host preference?
Yeah, it's not something we've incorporated at the moment. I do actually have a master's student trying to answer that exact question, so hopefully in a year's time we'll have some interesting results. Yeah, resistance to everything else you've thrown out for mosquitoes has developed, so it would be very naive to think that, it's something that would not need to be looked at for ivermectin.
To add on to that, ivermectin is a different mode of action from pyrethroids. And I think everybody is suggesting that it would be in combination with other vector control measures as well as anti-parasitic measures. So the mode of action is different. So you're basically getting combinatorial therapy against the mosquitoes if you give it with a new pyrethroid bed nets and put out ivermectin. Possibly preventing resistance development for both. And then if you throw on maybe an IRS with another different mode of action, you might get up to 3 or more combinations. Potentially.
I think that the key word is complementary. I think everyone here is ambitious. This is a complementary strategy and not a standalone tool.
My turn? Oh. Yeah, and follow up on the former question is that one of the things I noticed, and I didn't see a lot of the earlier, couple of the earlier talks, but there was always a residual population that was ivermectin resistant, that lived. Now, it was a small population, similar to what we used to see with some of the organophosphates and the chlorinated hydrocarbons. Has anyone yet challenged those residual populations that lived to see if there is true resistance? Now, this is important because if they are resistant, you can see resistance occurring really quickly. The reason I follow up on that is that we've been treating dogs for dog heartworm, Onchocerca volvulus, now for 25, 30 years with ivermectin. And I have not seen any publications, or maybe you people should, see if there is any insecticidal activity in Culex pipiens, Culex quinquefasciatus, and tarsalis. And if there is resistance, because we still have a major epidemic of Onchocerca volvulus in the United States. So just something you guys want to think about.
So in my lab, we've tried to select ivermectin-resistant Anopheles gambiae. Tried that for about 1.5 years, and it failed miserably. Now, we could say that the genes, it wasn't a diverse enough population, although it was recently colonized from Burkina Faso. The problem is that the dose you need to put pressure on the direct adults really inhibits egg production. There's multi-effects going on in the mosquito, and it's not just direct killing, targeting the glutamate-gated chloride channels. There seems to be some weird things going on in the midgut of the mosquito, possibly messing with endocrinology. And so 1 nanogram per mil in a blood meal, which doesn't affect the direct survivorship of the mosquito, will give you significantly less eggs. So it was really, we couldn't select. Yeah. But of course, so the best thing that has to be done is in the field, but nobody's giving it out repeatedly until these trials happen. And the field also has a more diverse population of genes, and so maybe it's start to...
Yeah, that's one of the things we found out looking at a lot of the insecticides, is that really when you start using colonies tend to fix real quickly. And so you're not really getting a clear picture of the genetic identity of that population. So Really, the challenge is what we did, go back to the field and use early generations, P1s, maybe no more than F2 generations. And again, a lot of this can be done with Culex right here in the U.S. to get at least to develop a model. Thanks a lot. Good talk, by the way. You guys did a good job.
We're going to take one last question.
Yeah, just a quick question about the distribution of ivermectin in red cells. Do you have some, the concentrations have been shown here, are these plasma or whole blood?
These are whole blood concentrations. Yeah.
Okay.
In grams per deciliter is what we showed. Okay.
All right, I think that concludes our session. So thank you all very much for attending. I hope you took away some good points.